Okay, so this next little piece, we are talking about what are referred to as measures of central tendency. And these are things that you have done before. So today should be basically a review from middle school. We're talking about measures of central tendency, which are your mean, median, and mode. Okay. We'll start seeing some of the notation that's used. We have a difference because we can calculate these things for a sample or for an entire population. And a lot of times they use different variables to denote those. The calculation is the same, but it's just so that if you're looking at your problem, you know, was this number for the entire population I'm concerned about or just the sample that we had? Okay, so measures of central tendency. We are trying to find the center. Central tendency, it's just how we can find the center of our set of data. And the one that everybody is most familiar with is the mean. What is a mean?
Middle.
The average. And how do you find that? Okay. Just notation. When we're talking about a sample, we use X bar to represent the middle. When we're talking about a population, we use this, looks like a U with a really long tail in front. It's called a mu. It's a Greek letter. Almost always we'll have a sample because it's hard to find the entire population. But I just didn't want you to be confused if you see different variables. They're both talking about just the average. Add them up, divide by the total. So we're going to just calculate a mean here. First example, the following data represent the travel times in minutes to work for all 7 employees of a startup web development company. So if it's all 7 employees, is this the population or the sample? Population. It's all of the employees, so it is the entire population here. And in part A, I said compute the population mean. So the variable we use for population mean is mu, this long-tailed U looking thing. And you will just add up and what will I have to divide by? 7. So we get 174 divided by 7. So our population mean, I got 24.9 approximately. So the average commute time is almost 25 minutes. Part B. Take a simple random sample of 3 employees and compute the sample mean. So I'm just saying we're going to randomly pick 3 of them. All right. We know we can do that a couple different ways. You could do a random number generator or something. Let's say I pick those 3. How would I find my population mean? Or sorry, my sample mean? The only difference is my notation now, that's X bar. And I only have 3 points, so I'm dividing by 3. And I get 26.7 approximately. So you notice, are those two things the same? No. If I picked a different sample of 3, would I have gotten 26.7 again? No. So this is just one of the dangers. We know that if I take a sample, is the actual numerical value going to be the same as the whole population? Rarely. Okay, there's always going to be some difference. But we will be working on this class about what kind of conclusions can I draw from my sample. So I just wanted to illustrate that those are not the same, but calculation-wise, we do the same thing. Is that good? Next thing we have to find is a median. In here, capital M represents median, and that is just the middle. When your data is in order from small to large, so it has to be in numerical order, and then the point in the middle is the median. So I'm using the same set of data, my travel times from my 7 employees. If I want the median, we have to first, and this is the most common mistake, they have to be in order, small to large. So my smallest is 5. Next I would have 18, 23, 26, 36, and 43. Then how do you find the middle? Yeah. Basically, we want to work our way in, so like those two cross off, these two cross off, these two cross off, and I'm left with, our median is 23. What if there is more than one value? What if I was left with 2 values there? What do we do with them? Yeah, have to add, which I'm adding up and divide by 2. Good. Okay, so same scenario, but now we've hired a new employee, and this one has a 130-minute commute. How does this impact the value of the mean and the median? So I want to recalculate both of these things. So my mean, this is the whole population, so it's my mu. Add all these up and divide by what now? 8. So add up all 8 values, so the 7 that we already had, plus the new 130-minute commute. And I get a mean of 38. How does that compare to the mean I had before? Yeah, that was a significant increase there. And that happened because this 130 minutes is significantly larger than all the other numbers. Okay, let's do the median. So if I put these in order from small to large, and then if we start crossing off on the ends, so first and last, working our way in, I'm left with 2 values in the middle. So we have to add those up, divide by 2, I get 24.5. How does that compare to the previous one? Yeah, it's a small increase. Okay. So this kind of illustrates the point. We'll talk about when is the mean better and when is the median better. And it has to do with points like the 130. That's called an outlier because it's way different than all the other points. So if we have these extreme values, something that's way bigger or way smaller than all the other points, the median is going to be more accurate. But if all my points are pretty close together, which one is really a better indicator? The mean, the average. Okay, so what we call this, the median is what we call resistant. And resistant is just when your extreme values don't make a significant difference. You're kind of illustrating what's going on. So it's up to you if you want to draw this or not. It is in the textbook on page 123 if you don't want to draw this. So this is what's going on when I compare the mean and the median for different sets of data. Okay, the center, if you have symmetric bell-shaped data, then the mean and the median are pretty much the same. They both give a good indicator of the middle of our data. So when it's bell-shaped, the mean and median are equal. If it is skewed left, that means you have a lot of really low points. If you have a lot of low points, what does that do to your mean? Yeah, it's going to drag my mean down, but my median, my middle, is going to kind of still stay in the middle of our data. So if you have a lot of really low points, that mean is going to be smaller than the median. If we have a lot of really high points, what's going to happen to my mean? It's going to get higher. So in that case, if you have a lot of high points, then the mean is going to be higher than the median. So you can kind of tell the shape of the data if all you know is the mean and the median. If they're really close to each other, it's pretty much bell-shaped. If the mean is a lot higher than the median, that means it has to be skewed right because we have a lot of high points. If the mean is significantly lower, that would be skewed left. We would have a lot of low points. Does that make sense to everyone? We have a really huge set of data. It's going to be very time consuming to get that. So in this class, we kind of work smarter, not harder. Okay? If there's an easier way to get it, we want to use that. So we are going to utilize our calculator a lot. When things get ugly, we're going to talk about some of the shortcuts. So let's say this data represents the asking price of homes for sale in Lincoln. Okay? Now, could we add all these up by hand and divide? Absolutely. But I wanted to show you how to do that on your calculator. So we need to go to we're going to go to Stack, Edit, and we want to put all this in L1. Now remember, if there's stuff in L1, you can go up to the title, hit Clear, not Delete. I don't want you to delete out your list. And so then we are going to type all of these values in our L1. Make sure that you're not making mistakes. You should have 16 points entered when it's all said and done. We can go to Stat. So we start out Stat Edit to put our list of data in. We're going to go to Stat, and we want to go over to calculate, and we want the first one variable statistics. Okay, now as long as you put your stuff in L1, this slide we can just enter through. We don't have to change anything on this screen. And then it brings up a list of data for me. Something's off. Did I type one of my points wrong? Okay. I guess that is right. Never mind. So, if I wanted the mean, which one is my mean? Mean is X bar. So that's 123, 193. .375. So it does everything for us. The median. If you push the down arrow, it'll keep giving you stuff. It says MED for median. So that's 127,925. Okay, so if I wanted to know how this was skewed, okay, if it was bell-shaped data, what would be true about my mean and the median? They'd be the same. If I'm looking at this, my mean is smaller. So that means it is, there were some low points that drew my mean down, so it has to be skewed left. And we could look at a histogram or something to confirm that, but I'm not going to right now. Are you okay with that? So the one thing that we haven't talked about yet, we've talked about the mean, we've talked about the median, so the last one is mode. What is the mode? The mode is the most frequent observation. Okay, you might have more than one mode. If you have 2 points that each pop up 3 times, you could have 2 modes. If nothing occurs more than once, then in that case we say we have no mode. So you might have one, you might have more than one, you might not have any. Let's look back at that set of data that we've used over and over again. So for our 7 employees, what would be the mode of this set of data? 23. It showed up twice, no other points showed up twice. If I said I had an 8th employee with a commute time of 43, then what would my mode be? 23 and 43. Okay. If we fired one of the people that had a commute time of 23, then what would my mode be? Yeah, if I didn't have that 8th person, it would be none. If I still had that 8, it would just be the 43. Okay. So mode is good. All right, I just want to do 2 more quick examples and I'm done. So let's say we have a set of data and our values are 11, 15, I'm missing 1 point, 24, 29, 31. The median is 20.5. Can we find the missing value? So I want to try working backwards here. It's not that bad to calculate mean, median, and mode, but what if we know one of those? Can we find a missing point? So how do we find median? Median is the middle. These are already in order from small to large, right? So I'm just going to call this one X for a moment. So if I were finding the median, these 2 would cancel out, these 2 would cancel out. What would I have to do with these? Divided by 2, and what does it equal? Median was 20.5. So then we can solve this equation. Multiply by 2. Subtract our 24. Get the missing value of 7. Is that one okay? one, I want to look at an example in your book. Alright, so on this one, Mr. Zero finds the mean height of all 14 students in his statistics class is 68.0 inches. Just as Mr. Zero finishes explaining how to get the mean, Danielle walks in late. Danielle is 65 inches tall. What is the mean height of the 15 students? So I didn't give you the other 14 heights. If I did, it would be no big deal. But what I did give you is the average of those 14. Okay, how do you find that mean for those people? Okay, so since I don't know the points, I don't know what it added up to. But I would have divided by 14, and we got 68 inches. So now we could find my x. So this is the sum of the first 14 heights. So when Danielle walks in, what do I have to do to find my mean? We have to add everybody up and divide by 15. Well, I don't know the first 14 values, but I know they added up to 952. Plus, how tall was she? And then I would divide by 15, because now there's 15 kids. And we get a mean of 67.8 inches. So you don't always have to have the original data. Sometimes we can work backwards there. Alright, so it's good with everybody? So we've got about 15 minutes. Here is your assignment. You don't have to, but on number 19, it's asking you to find the mean and median for two different sets of data. I would just use the calculator on that one. You don't have to. You can certainly do it by hand, but you're also welcome to kind of practice that, because as we go on, especially after we get out of this chapter, we're going to do this on the calculator almost all the time. So if you want to practice one on the calculator,